when we're trying to solve some exponential equations, it's best when I have the bases being equal to each other, because if the bases are the same, then the powers would be the same. In these two problems, they're not the same. However, there is something that I notice. In part H, when I have 3 to the x minus 4 is equal to 9 to the 2x plus 5, that 9 is a power of 3. So I can leave the left side the same, 3 to the x minus 4. But the thing is, when I write the right side, it'll still have the power of 2x plus 5. I just want to look at that 9 as being 3 squared. So on this right side, I have a power raised to a power. That means I have to multiply those two together. The left side will stay the same, 3 to the x minus 4. But on the right side, the base is now 3, but my power, when I multiply those two together, will be 4x plus 10. Rewriting it this way gives me two exponential expressions that are equal to each other. They have the same base. That means that their powers have to be the same. X minus 4 has to equal 4x plus 10. Once we have that, we just solve it like normal. Subtract x from both sides, so I'll have 3x over here. Then subtract 10 from both sides, negative 14 is equal to 3x. And finally divide by 3, so x is negative 14 thirds. Let's do the same thing with 2 to the 3x is equal to 8 to the 4x plus 1. 8 is a power of 2. So that means on the left side, I'll leave it alone as being 2 to the 3x. But on the right side, that 8 can be rewritten as a power of 2. I'll leave the power alone for right now, but 8 is 2 to the third. So taking power to a power lets me rewrite this, leaving the left side alone. But on the right, I'll take power to a power, so I'll multiply 3 times 4x plus 1, and I'll get 12x plus 3. Now I have two exponential expressions that are equal to each other. They have the same base, so that means that they have the same power. That 3x has to equal 12x plus 3. Solve it like normal. I'll subtract 12x, giving me negative 9x is equal to 3. Then divide by negative 9, so x is 3 over negative 9, which is negative 1/3. And there we go.